Good day, everyone. I am Ma'am Sheila, and I am here to help you on your Mathematics 10 lessons. Today, we will be talking about sequence. So at the end of this lesson, you will be able to generate pattern from a given succession of objects, numbers, letters, or symbols. Also, you will be able to find the nth term of a sequence and write the rule of the nth term of a sequence. So before that, we will be having an activity first, entitled What's Next? Number 1. What is the next shape? Square, triangle, square, triangle, square, triangle. What is next? Square. That's correct. How about number 2? What is the next number? 0, 4, 8, 12, 16. What is next? 20. That's correct. Next is the stack of coins. On the first stack of coins, there are 2 coins, followed by next stack, which has 5 coins, and followed by 8, 11, and 14. Now, what do you think is the number of coins on the next stack? 17. That's correct. And now we are ready to talk about sequence. But before that, let us define sequence first. It is a succession of characters in a specific order. Now, sequence has the big word order. Also, sequence is a function whose domain is the finite set or the infinite set. And sequence has 2 types: finite sequence and infinite sequence. Finite sequence. It is a set that has a finite number of elements. Example: 2, 4, 6, 8, 10. The last element is defined. Infinite sequence. A set that has an infinite number of elements. Example: 2, 4, 6, 8, 10, and so on, meaning the last element is not defined. And at this time, we will familiarize the nth term of the sequence. That is denoted as A sub n. Example, in the sequence 2, 4, 6, 8, 10. 2 will be denoted as A sub 1, meaning that is our first term, and our n is equal to 1. 4 will be our A sub 2, that means our second term. 6 will be our A sub 3, that will serve as our third term. And the fourth term, which is denoted as A sub 4, is 8. And 10 is our A sub 5, which is our fifth term. And also, our n at this time is equal to 5. At this time, let's have example number 1. Generate the first 5 terms of the sequence given the nth term A sub n is equal to 2n plus 3. That means A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5 will be the unknown. So first is, we are going to find the A sub 1, or we are going to find the first term of the sequence. So first, you have to identify the value of n. N is equal to 1. Where did you get 1? That is based on a sub 1, first term. Now refer to the given sequence. A sub n is equal to 2n plus 3. Next is, you are going to substitute n by 1, meaning you are going to replace variable n by 1. Why? Because n is equal to 1. So that becomes a sub 1 is equal to 2 multiplied by 1 added by 3. Next is you are going to simplify. In simplifying, do not forget to follow the PEMDAS. Therefore, a sub 1 is equal to 2 plus 3 because the product of 2 and 1 is 2. Then, a sub 1 is equal to 5. That means that the first term of the sequence is 5. Let's have another one. Find a sub 2. Now again, you have to identify the value of n. And at this time, n is equal to 2 because we are looking for the second term. And refer to the nth term, a sub n is equal to 2n plus 3. At this time, you are going to substitute n by 2. What makes it 2? Because at this time, n is equal to 2. So that becomes a sub 2 is equal to 2 multiplied by 2 added by 3. And the next step is you are going to simplify. So that becomes 4 added by 3 because 2 multiplied by 2 is 4. And simplify it again, and that leads to the second term of the sequence, which is 7. So we already have discussed on how to find the first and the second term of the given sequence. You may pause this video for you to find the third, the fourth, and the fifth term of the sequence. Now, if you are done, remember that a sub 1 or the first term is 5. The second term is 7. And the third term will be 9. Fourth term is 11. And fifth term is 13. Meaning 5, 7, 9, 11, and 13 are the first 5 terms of the sequence. Let's have example number 2. Find the 7th and 9th term of the sequence a sub n is equal to n squared minus 20. So at this time, we are going to find the a sub 7 and the a sub 9 only. So find the 7th term. To find the 7th term, the value of n at this time is 7. That's correct because we are looking for the 7th term. And again, refer to the given sequence. A sub n is equal to n squared minus 20. Substitute n by 7 because again, n is equal to 7. So that becomes a sub 7 is equal to 7 squared minus 20. And following the PEMDAS, simplify. So the first thing that you are going to simplify is the 7 squared. And that becomes 49 minus 20. And that leads to the seventh term, which is 29. Okay? Now at this time, you will be going to find the ninth term. Your turn. The ninth term is 61. Did you get the correct answer? Good job! Let's have example number 3. In example number 1 and 2, you are given with a general term and you are asked to find the first, the second, the third, and even the ninth term of the sequence. Now at this time, let's do the reverse. You are given with the first 4 terms, 4, 7, 10, and 13, and you are asked to generate the general term of the sequence. Note that each term is added by 3 from the previous term, meaning 4 plus 3 is 7, plus 3 is 10, plus 3 is 13. To do that, let's have this table containing term, value, and pattern. Under the first row, the term is 1 and the value is 4. That means that the first term is 4. On the next row, the term is 2 and the value is 7 because the second term of our sequence is 7. And under the first column of the pattern, we have 4 plus 3. 4 comes from the first term of our sequence. Plus 3 because as what we have observed on this sequence, first term is just added by 3 to have the second term. And that leads to this part of the table, 4 plus 3 times 1. Why 3 times 1? Because 3 is added to 4 and there is only 1 3. Next, the term is 3 and the value is 10. Under this column, 4 plus 3 plus 3, the 4 plus 3 comes from the previous pattern and just added by 3. And that leads to this part of the table, 4 plus 3 times 2. What makes 3 times 2 at this time? Because 4 is added by 2 number 3's. Now, do you have any idea on what will happen to the next row? On the next row, the term is 4 and the value is 13. Under this part of the table, number 3 is multiplied by another number 3. Therefore, if your term is 4, 3 is multiplied by 3. If term is 3, 3 is multiplied by 2. If term is 2, 3 is multiplied by 1. If term is 1, 3 is multiplied by 0. Now what will happen if the term is n? What will be multiplied to 3? That is n minus 1. So now, that leads to this part of our solution. A sub n is equal to 4 plus 3 times n minus 1. And then, we are going to generate the general term of the sequence out from a sub n is equal to 4 added by 3 multiplied by n minus 1 by applying the distributive property of multiplication. That means you are going to multiply 3 by n and multiply 3 by negative 1. And that leads to the answer a sub n is equal to 4 plus 3n minus 3. 3n because the product of 3 and n is 3n. And negative 3 because the product of 3 and negative 1 is negative 3. Next is you are going to combine similar terms. 4 and negative 3 are similar terms because 4 and negative 3 are constant terms. So to combine, that becomes a sub n is equal to 3n plus 4 minus 3. And then simplify, that is a sub n is equal to 3n plus 1. Therefore, the nth term of the sequence or the general term of the sequence 4, 7, 10, 13, and so on is a sub n is equal to 3n plus 1. Now, let's try to check our work. Using the generated nth term a sub n is equal to 3n plus 1, we are going to verify if the fourth term is 13. Therefore, we have to substitute n by 4 because again, we are talking about the fourth term or a sub 4. So that becomes a sub 4 is equal to 3 multiplied by 4 added by 1. And then simplify, so that becomes 12 plus 1, and the fourth term is 13. Correct! The fourth term of the sequence a sub n is equal to 3n plus 1 is indeed 13. Do you understand our lesson? I hope you do. Now, if you follow the instructions, then you are doing a good job. Thank you for listening. Have a good day, everyone.